All right, we're going to start with derivatives of trig functions. So we're going to start with the sine and the cosine. Those are our ones that we use most frequently, obviously. And so just I'm making a little chart here. So over here on the left is the function itself, sine, cosine. And on the right is the derivative that goes with it. So the derivative of the sine is the cosine. It's kind of easy to remember. But when you go back the other way, it's not what you would like it to be. You'd say, oh, it would be nice if the derivative of the cosine was the sine. It's not. It's the negative sign. So this is something that you're going to have to memorize. That negative sign is going to mess you up all the time until you get really, really comfortable with it. Just remember, the derivative of the sine is not changing the sign. Derivative of the cosine is changing the sign. So let's see how we work with this. But let me show you one interesting fact about the two of those. So first of all, if you recall, imaginary numbers, when you square them and cube them, there's a cycle. Well, sine and cosine do the same thing. So I'll show you right now. So if we say, here's our function, the sine, and we take the derivative of that, we get the cosine. If you take the next derivative, you keep taking derivatives. So this is the second derivative. Notice the derivative of the cosine is the negative sign. Now I'm going to take the third derivative. Well, the derivative of the negative sign, the negative sign comes down, and because it's -1, right? So it's that constant multiple rule. And the derivative of the sine is the cosine. So now I have the negative cosine. That's the third derivative. If you take the fourth derivative, I'm just writing it this way, the f to the 4x. It's not to the fourth power. It's the fourth derivative of x. Then it's this negative cosine, but it's the negative of that. So it's negative sign, which goes back to the sine. So every 4 derivatives, they loop back around again. So, for example, the rule would be that if the function is at sine, then the fourth derivative is the same. The 8th derivative would be the same. 12th, 16th. Every multiple of 4 is going to have the same answer. It's going to be the same. All right, let's look at some examples of our derivatives here, my friend. Whoa. It took 2 pages to show. So let's look at a chain rule version of this. So I have 5x cubed times sine x. So we're going to separate this into our u, which is 5 sine cubed, and our v, which would be sine x. So here's my u. There's my v. Now, I'm going to write u prime. I'm going to start writing, as we move forward, the du in the differential form. So just you'll get more comfortable with that. So if you see this du, it's the same as just u prime. The derivative of this, the du for this, is 15x squared. And over here, the v prime, or dv, as the case may be, the derivative of the sine we just learned is the cosine. So there's my 4 components, my 4 pieces that go into my formula. Here's the u, right there. Here's the v prime, right here, plus v u prime, or dv. And that is the answer. We can look at a quotient rule version of the same exact thing here. So we've got cosine x over 4x squared. So again, this is u over v. So my u is cosine, my v is 4x squared. And then my u prime, or du, would be negative sine x. And my dv, or v prime, would be 8x. And then I plug those pieces in. So here's v u prime, minus, remember it's minus with the quotient rule, u v prime. And that whole thing is over v squared. So 4x squared squared. And remember, if you multiply that out, my friends, everything in here is squared. So some friends might want to say, oh, it's just 4x to the 4th. No, in this case, if you did that, it would be 16x to the 4th, right? So just remember that. Looking at the rest of our trig functions, tangent, cotangent, secant, cosecant, they have somewhat weirder derivatives. The derivative of the tangent is the secant squared. And the derivative of the cotangent is the negative cosecant squared, kind of like that relationship we saw with the sine and cosine. The weird one, which will come back to haunt us in many different ways, is the secant. And when I say weird, the derivative of the secant is the secant tangent. So the weird part is that the secant is in its own derivative. So it doesn't go away. It actually is added on. It kind of accretes as you're moving on. So you can imagine if I take a second or third derivative, things get kind of messy. And likewise, the derivative of the cosecant is the negative cosecant cotangent. So those you would have to memorize. And again, you're going to memorize them because you're going to use them so frequently. These, probably not as frequently, but certainly the sine and the cosine. Let's look at some examples here. So here's one that says cosecant x plus x tangent x, and we want to know the derivative of this function. Well, remember, when we're adding, we just take the derivative of each piece separately. So the derivative of this piece, the cosecant, is just from that chart I just showed you. So that's the negative cosecant cotangent. Nothing to do there. Just fill in that. Plus, then this x tangent x, that's a product rule. So my u is x. My v is tan x. Well, my du is going to be 1, right? The derivative of x is 1. And the derivative of the tangent is the secant squared of x. So I'm going to put that information into my product rule. U v prime plus v u prime is just 1. Du is just 1 in this case, so I don't do anything. So here's my answer right here. I put the brackets here to show you that this chunk is the derivative of that. And let's see, what else do we have? Oh, here's a good question. This is a really good SAT question. They do this either with sine and cosine or I, imaginary number I. It's a super common SAT question or GRE question if you're going to grad school. So they say, what's the 74th derivative of the sine of x? And most people, if you don't know, you're going to flip out. I can't do that. And the idea is, if you don't know, you can try and do it, but it's going to take forever and it's going to take time away from your from the test, which they're always timed, right? But if you do know, it's very quick. So we know, and I showed you before, that every multiple of 4 loops back on itself. So 72 is the last multiple of 4 before I get to 74. So as soon as I get to 74, I'm starting all over again. So the 74th derivative of the sine of x is the same as the second derivative of the sine of x. Because 72 is starting over, 73 would be the first derivative, 74 would be the second derivative because it loops. Every 4, it loops. And so then we say, oh, that's easy. The derivative of the 72nd one is sine, 73rd one would be cosine, and the 74th one would be negative sine again. So pretty easy to do there. If you know, if you don't know, you're in trouble. And we have a physics example here. So we have a particle that's moving with this position function, 2 minus sine t. And the problem asks us to find the velocity at pi over 4 and the acceleration at pi over 4. And so then we say, okay, well, the velocity function is the first derivative of the position function. So the derivative of this, well, the derivative of 2 is just 0. So the derivative of negative sine is negative cosine because the negative carries, right? And so then we say, well, what's the velocity at pi over 4? I just substitute pi over 4 in here, and we know that the cosine of pi over 4 is square root of 2 over 2. And my answer is negative square root of 2 over 2. No worries. Again, we repeat the process. Now we want to know what the acceleration is. Well, the acceleration is the second derivative of the position function or the first derivative of the velocity function. Well, here's our velocity function. So we just take the derivative of that. Well, the derivative of the cosine is the negative sine, but there's already a negative here. So this is negative sine, which would be sine. So then we evaluate that at pi over 4. So the sine of pi over 4 is just square root of 2 over 2. And this is going to be kind of your bread and butter for a while. Chain rule is on steroids when we have trig functions. I'll show you two beginning ways to do this. We're going to have all sorts of examples of this. I'll be happy to show you. The first is when I have a number here that's attached to my argument right here. So so instead of the sine of x or cosine of x, there's something going on here. So this is sine of 2x. So in this case, this chain rule, I'm going to substitute this with u. So this becomes the sine of u. And so then I'm going to say, well, what's the derivative of the sine of u? And that's the cosine of u right here. But then we have to add on that du, that u prime. And the derivative of this is 2. So the derivative of this is cosine of 2x times 2. That's one way of doing it. The other way is where the trig function is the inner function, not the outer function like it was here. So in this case, let's say that I have cosine x squared, the function squared. And remember, it can be written like this. So this is very tricky. When you see that squared here, these are the same thing. So in this case, the outer function is u squared. So then we say, well, what's the derivative of u squared? Well, it's 2u u prime, or du. So here's 2u, because u is my cosine of x. What's the derivative of the cosine of x? Negative sine x, and that goes right there. So I have 2u du. All right, and we're going to practice a whole bunch more of these. You're going to get quite good at this, my friends.